Okay, good morning everybody. Yesterday, I guess we stopped at this point. We talked about primitive types versus the reference types. We said that two types of variables or types there in Java. One is the primitive types, which are the Booleans, bytes, characters, shorts, and integers, etc. These are the same as C++. No difference. The other one is you may call this part as smart pointers, references. References are smart pointers. They hold pointers or references to the objects, and their default value is null. Null pointer, you may think of it as it is. Okay, and we use them to point to the objects and to invoke objects methods. Okay, they are called references. Yesterday I forgot to mention this one. This is a very important feature of Java. Java says that I guarantee that integers are 4 bytes. That's it. And floats are such and such. Doubles are such and such. Okay, that's guaranteed. Okay, their sizes are not machine dependent. Why? How come Java can make such a guarantee? Instead, C doesn't make any guarantees like that. For C, who said that? Did you? You said okay, because Java uses the virtual machine, right? Virtual machine is, as the name implies, this is virtual. It is in software, okay? So you can emulate whatever you want. You say that my integers are going to be 4 bytes and they will be 4 bytes. You implement it. If the underlying machine doesn't use 4-byte integers, then your virtual machine has to do more work to emulate 4-byte integers. But at the end, your Java program, your bytecode will work, assuming that integers are 4 bytes. So that's guaranteed. Okay. So I mean, this is no. I mean, well, it sounds like a nice property of Java, but in Java we don't deal with the sizes of the objects. Because why are the sizes of the objects important? Because we have to know them to increment our array pointers and doing that kind of struct or union kind of structures and etc. That's why they were important. But in Java we don't do that kind of low level byte related stuff. But it is nice to know that. Okay, I mean, it is nice to know that the sizes are not machine dependent. Also, it is important to know that why Java can make such a guarantee, and why this feature alone makes Java virtual machine a little bit slower than the alternative classically compiled languages. Okay, so we will come back to this, the differences between these two more. And with the primitive types, all you say is that I have an integer I, a local integer, its initial value is 7. Okay, then you don't have to do anything else other than doing this. But for the reference objects, for example, let's say I have a money class. When you say money m is not a money object, it's a money reference. You have to initialize it with a new operator and money such and such. Okay, so that's the only way to make a regular Java object using the new operator. Other than that, you don't have it in Java. In C++, of course, you have your constructor calls. Okay, you call your constructor, you make a money object, or you can use the new operator to make a money object on the heap. Okay, good. So here is another program. Very simple program. I will show you two files: gradebook.java and gradebook.test.java. Let's look at this gradebook.test.java. This one includes the main method. It says that, as you see, I don't have any imports, I don't have any includes. But in my main method, I say that I will have two gradebook references, gradebook 1, gradebook 2. And I'm going to initialize them with two gradebooks. Okay. And after initialize them, I will say system out printf gradebook1.get course name. It will print the course name, this one, CS 101 Introduction to Java Programming. And then gradebook 2 get course name it is CS102 data structures in Java. That's it. That's the whole program. And when I run it, I will get these messages on the screen. The thing is this: how come Java? How does Java know where to get this definition of gradebook? Because you don't see any import statements in here, you don't see any include statements in here. The thing is that this gradebook test class, this is a class, right? This is a gradebook test class, and the gradebook class, both of them, they are in the same directory, and Java has this property of finding the related class if they are in the same directory, or sometimes we call it if they are in the same package. Okay, so you don't say that there is a gradebook available and it has this and this member functions, member methods, and etc. You don't say that. If the gradebook and the dot class and gradebook test dot class are in the same directory, then you should be fine. Okay, they are in the same unnamed package, and we are going to talk about the packages in a few minutes. Okay, so this is the grade. You may think this as a driver code. Actually the driver code is the main method, but you have to write a class for that. Okay, let's look at the gradebook class. I have a private string in it. It is not initialized as you may have expected. This is the constructor. The function of the constructor, the convention of the constructor naming, and the way we write constructor are almost the same as in C++. The same name, it takes a parameter. It didn't have to say take a parameter. You may overload the methods or the constructors if you like. And here is what I did. I get a string name, okay, and look at this one, okay. This is an assignment of what? Assignment of line 11. What is it? Is it an assignment of what? What kind of assignment is that? Assignment of
reference.
Assignment of, yes, exactly. MG, RGMG. Assignment of string references. Okay, this is not copying of the string. This is of assignment of string reference. Okay, in my memory, remember I made two gradebook 1 and gradebook 2. Okay, these are two references here. I have one, okay, gradebook 1 and gradebook 2. I have two references. These references will be assigned. Okay, one of them will be here, the other one will be there. Okay, so these are two gradebook objects. When I look at this gradebook object here, it takes a string from outside world. Okay, it takes a string from outside world. The one of the string is this. It says CS101, I guess, and the other string will be somewhere in the memory like this, CS102, right? Okay, so this one says that I am going to point to inside this one, because it's a gradebook, right? I am going to point to the CS101, and this one says that I am going to point to CS102, but this doesn't make any copies. Okay, this is an outside object or outside memory location. This doesn't make a copy. It just makes a string reference copy, shallow copy. And as a C++ programmer, when I look at this, I am kind of worried about what happens to the original string if they change it, right? If they change the original string, I am holding a reference to it, I might be in trouble, right? It's like this. Let's try to write this one. Okay, let's say string S3, okay, and it is initialized with, this is the way Well, let me use a regular way so that you don't get confused. New string A, B, C, and then I make a new gradebook object, gradebook GB3 S3. Okay, this GB3 just copies the reference of S3 into its gradebook string. Okay, but what happens if I later change this S3? So this GB3 will be affected that too, right? So it looks like maybe I should have done a deep copy of the string itself, but no, I don't have to, because string is kind of a special class in C in Java, because string class is an immutable class. Okay, immutable. It doesn't change. It doesn't have any functions to change the string data members. String data members. You cannot change it. You cannot add more characters to a string. You cannot modify one of the characters of a string. It is constant. Okay, it is called immutable class. So it is okay to have this kind of reference copying with the string. Okay, you might say that what happens if I delete the string? But there is no deleting in Java, right? There is no deleting. As long as the reference count is above 0, it will stay alive, and that's going to be okay for me. So it's kind of a solution for the strings. But if you have any other classes that are possible to change, you should not do this. You should maybe do a deep copy. Okay, and for the deep copy, you need to call the clone member method of the object itself, and we are going to see it later. Okay, so string is special. You cannot change strings. What happens if you need to change the string? Well, you make a new string. Okay, you make a new string. That's kind of inefficient, but that's the way it is. So for the strings you don't have plus assignment operator. You have it, but it makes a new string. Okay, good. So this is my setter. Okay, this is my getter. There are no const keywords in Java, so you don't see any const for the getters. Okay, Java methods doesn't make any guarantees about I am going to change this object or not change this object. Okay, they are just const or no const. Java doesn't make any distinction between those. It looks like a bad feature in terms of principle of least privilege, but it is the way they design. They say that we have other ways of doing that kind of stuff, and I think you are going to see one of them later. So don't forget about the const keyword. There is a final keyword, but it is meaning it's overlap, but it is not the same thing. Okay, so you don't put const at the end of this line to anyone. You don't make any guarantees that I am not going to change anything, etc. Okay, good. And this is my display message. This display message makes a printf call, and I'm going to print something as string and get course name, and it is printed. That's it, and that's the end of class gradebook. No semicolons. Okay, very simple class pair. I wrote two classes for this whole program. I wrote two classes, but previously, I think yesterday I showed you this one, right? Where was it? I think it was one of my, maybe this Advan.java. This guy did not write two classes in a single class, okay? One function and one main. Since main is a static data member, is a static method, I can write it anywhere. So I am making a I am making a, maybe I shouldn't do this. Let's do it back. Okay. I'm making an object of my class. I can make an object of my class, of course, and I call it num of my class. Okay, so that's how I wrote. How come I can't do that? Okay, why don't I do this? Because this main is part of the same class, right? Why don't I call add num directly instead of saying object that I add num? This is a C++ question, not Java question.
Static method doesn't have an object.
Exactly. Did everybody hear it other than myself? No, they didn't hear it. Say it louder.
Static method doesn't have an object.
Okay, 3 more people heard it. Okay, thank you. He said, our classmate is saying that this is a static method. Static method cannot call non-static methods. Okay? You need to have an object, okay, to make, what did I do? Because, so I don't know how to come back. What did I do? I was trying to delete something, so it is writing from right to, what? I discovered something. What is this? What is it? I invented a new way of indentation. I hope it doesn't save this behavior. No, don't save it. Let's try to open it again. Yeah, okay. So I have to do this. I have to do make an object, and it's I mean the rules are the same. I mean you cannot call a non-static method from a static method because this one needs an object. Okay, good. So that's why I mean this guy did not write 2 classes. 1 class was enough. But the regular way of writing stuff is the way we wrote it. Okay, the way we wrote is just this is the gradebook class, and to test the gradebook class you write another test class, and inside that class you have only usually a single main method. Okay, any questions so far? There are no questions. Let me move on. So all the control statements, if, else, switch, they are all the same. All the loops, while, for, do, while are the same. Compiled assignments, pre-increment, post-increment, and decrement, they have the same effect. Break and continue have the same effect. Okay. Logical operators, they are mostly there, but there is a difference. There are no bitwise operators in Java, like the logical or logical and. Remember those? They are used for Boolean and or. This and or, this logical and or have the same effect, including the short circuit evaluation. Remember the short circuit evaluation? It has the same effect. If you don't like short circuit evaluation, then use this one and that one. And then or, okay? They always evaluate both sides. They don't do any short circuiting. They always evaluate left and right, okay? Remember left shift, right shift operators that we use for stream insertion extraction, but for the integers for left shift and right shift, okay? They are not there. I mean, you don't have any, as I said, bitwise operators in Java. Well, they have implemented in a way that, I mean, left shift and right shift, in effect, it means multiply your integer by 2 and divide it by 2, right? So they have implemented that, just multiplying it by 2 and dividing it by 2. This meaning is a little bit different from C case. In C case, it is shifting the bits actually, using the CPU features if available. Okay. And these are the promotion rules. What do I mean by promotion rules? You may promote a long to a float. You may promote a character to an integer, integer to a long, and etc. No, sorry. You may promote, okay, these are the promotion rules. Booleans are Booleans. They are not integers. They are not 1-0 thing. They are just true or false. Like C++ intends to be. C++ says that don't use ones or zeros to represent Booleans, but if you use them for backwards compatibility, I am going to accept them, but I don't like it. Java says that no ones or zeros for if and while and etc. Okay, always Booleans. For the bytes, I can promote a byte to a short, int, long, float, double, etc., but not characters. Okay, and for the short again, like that, but not character. And the promotion rules are like that. What do I mean by promotion? When you say 2 plus 1.5 integer and float, I promote this integer to a float so that I can do this float addition here, right? Okay, so these are the promotion stuff as expected. Okay, for Java API packages, there are many packages in Java. It's like libraries, or the as libraries we call in C++. Okay, there are many packages, and they are all defined inside this Oracle Docs website. Okay, for example, we have used this class from Java util package, Java utilities package. There is a scanner class. Okay, and when you import it like that, like the using statement, you get to use the scanner by its name, scanner. Okay, so remember, if you remember, we said new scanner and it made a new object. You can look at this Java API documentation by visiting this site. And can I do it here? Can I do it there? Can I do this? Yeah. Okay, let's go there. This is for Java Development Kit 7. Now we have Java 17. As I said, they keep changing this over and over again, but using an older version is not a very big problem. So these are the packages, Java packages. As you see, these are the packages that start with A only. Okay, let me try to make it okay. Java Applet, Java Abstract Windowing Toolkit. Under it, there are either sub packages or the classes and etc. Java Lang is a very important package. Java language. It is automatically important. It is automatically imported. Okay, you don't have to import it. It is automatically imported. And remember, string is defined inside this Java Lang. Okay, let's see what kind of things we have inside Java Lang. Okay, let's go find string. Okay, here is the string.
Sorry, we can't see that.
Why not? Maybe I should.
Yeah.
Instead of playing with the, I don't know who plays with that. Okay.
Yes, thank you.
So Java string is here, and so this is the name of the class. As you see, it comes from Java object. Okay, object is the superclass. Superclass means base classes in Java. Superclass of all the classes in Java. Object string comes from there, and this is how you. Okay. This is only valid for the string type of objects. Okay, I am making a new object without using new keyword. Okay, this is exception. Okay, you can't do that for your objects, at least for the Java SC7. Okay, and what's that?
It is dynamic memory.
You mean this one?
Yeah.
Well, as I said, string is a immutable class. Okay, you cannot change anything in it. You cannot add or remove stuff. But all the objects are created in the heap using dynamic memory allocation stuff. So you create a new object on your heap, but you cannot modify it later for a string. Okay. Okay, so this is my string, and let's look at some of the You remember this format? This is automatically generated by the Java doc utility. Okay, so you write your string class, you ask your Java doc utility to produce the documentation. It produces the documentation. It looks very much like the Java doc utility, Java doc HTML files that I produced yesterday, right? You remember those? Okay, so this is string my constructor. I can initialize it with some bytes using a different character set. There are many constructors. These are deprecated. What is deprecated? Deprecated? What's
It shouldn't be used.
It shouldn't be used anymore, right? I mean, I used to support this kind of a constructor in the previous versions of Java. I am still using it, I am still supporting it, but I cannot make any guarantees for the next release. For the next release of Java, this may go away. So stop using this constructor. So deprecated means, well, I am still supporting it. You may compile your program this way for backwards compatibility, but this is going to go away soon. That's what it says. Deprecated stuff. Okay. So as you see, you don't. Okay. So these are the methods. In Java, there is no operator overloading. Okay. That's why you cannot access the members of string using the index operator. Okay. They couldn't overload the index operator for the string class. Instead, they have character at. Okay. And what else? So you cannot see any methods that changes the string itself. For example, this concatenation. Concatenates the specified string to the end of the string. But I mean, this sentence kind of reads wrong. I am not modifying the string. I am making a new string and I am returning it. Okay, so you are not changing the string. So this concatenation is not the same as add something to the end of it. It is not like strcat in C. Okay, so these are all the documentation about string, and the point I was trying to make was that this Java packages, all of them are documented in this Oracle website. Oracle is the current kind of owner of Java. Java was invented by, designed by Sun Microcomputers Corporation, and Sun went bankrupt like 10 years ago, maybe. Java took it over. Oracle took it over. Then they are keeping all this documentation and everything, and it is very extensive actually. I mean, okay, I looked at this Java lang. We are going to come back to it later. Java math is here, another package. Okay, security stuff, RMI stuff, remote method invocation stuff, utilities. Remember, the scanner is part of this utilities. Okay, crypto stuff, image input output. I don't know. So many of them. JavaX means Java extensions, another package class. Okay, so these are some of the packages that the other institutions, other corporations kind of added to the Java, and they are accepted as standards. Okay. So many of them are here, some of them are not there, and if you look at Java 17, this is even more complicated. So people usually use Java because because of the extensive libraries available to it. Okay, because especially for the enterprise applications, it is very, very useful. So if you need something, you just go to. Remember, when I need something, I go to c++.com or c++reference.com and etc. For that one, okay, there is an owner of Java. Okay, Java is owned by Oracle, and Oracle keeps all that kind of documentation. It is the most reliable part site for the Java programming language. Okay. Good. Yes.
Scanner begins with upper letter, and the other of them, some of them is starts with lower letter. Is it implies something?
Well, if you look at this one, the convention is if you are making a new class, class names should start with a capital letters. Okay. And that's what we do, and that's what they are doing. That's the convention. They follow the convention. Let's go there and yeah. So all the class names, string, or let's go to, for example, this. Well, inside math, I don't think that we have any. Let's go to this RMI, remote method invocation stuff. Okay. So as you see, all the classes, they start with capital letter. These are the exception names, and they are classes, of course. They all start with the capital letters. And in object-oriented programming, including the C++, we try to follow this convention actually. For a class, start with a capital letter, and if you have more than one word, capitalize the second word too. Okay. Okay, we looked at this one. I don't know what I did again. Make it maximized like that. Yeah, good. So some of the packages, Java applet package. Okay. Applets are your small applications that work on the browser windows. What did I say? Java classes, Java bytecode can work on any virtual machine. So if I found a Java bytecode on the web anywhere, I can make it work on my browser window. This is my Chrome, okay? This is my Chrome browser window. And if I can get a Java bytecode from somewhere, this will work. I mean, this will work in this window, because all the browsers support the Java virtual machines, okay? But those applications would be specialized applications, and we call them applets, okay? So if you are writing applications for a browser window, you use the Java applets, you derive or you extend, in Java we call it extension, okay, not derivation. You extend your class from this Java applet, and it becomes an application that is runnable through a window, browser window, okay? But nowadays people don't like this anymore because it's a very big security risk. Running somebody else's code on your browser, because it's a full featured language, right? I mean, if I like, I can format your hard drive. I can steal all of your data if I can get enough privileges. So people don't like this feature of Java anymore. So they say that you should not run Java virtual machine on your browser at all. Usually by default it is disabled. You have to do lots of reconfiguration to enable it. Okay. So that's the Java applet. Abstract windowing toolkit about Java supports graphical user interfaces from the core of the language. So they have this standard package. Event is a sub package of it. Input output stuff. Java lang, we talked about this. This string class is part of this Java lang. And for the networking stuff, for the text-based stuff, utilities, sieving, again, it is for supporting the graphical user interface programming. So like this, there are many packages, and some of them we are going to see. It's like the STL, right? I mean, when I went over the STL, I didn't want to tell you the details of the STL. It is very detailed. There's lots of stuff in there. All I wanted to show you some examples of nice libraries, some nicely written C++ code. And I'm going to look at some of them, but I'm going to show you just give you for example, I like to talk about GUI, not because I like to do GUI programming. It is because its libraries are so so nicely structured. It uses polymorphism heavily, and and most of the time, very complicated graphical user interface programming can be reduced to a few simple lines of code using polymorphism and inheritance and the other object-oriented rules. And that's why I like to talk about them later during maybe next week. Okay, so let's move on. Let's talk about the scoping, shadowing, and overloading. Well, I mean, there is not much difference other than that. I mean, our main method has to be part of a class. So let's see one example of the scoping, shadowing, and overloading. Overloading has exactly the same meaning. You may use the same method name for different methods as long as their signatures are different, and the same definition of signature is the same as in C++. Name plus the parameters plus their types and their order is the signature. Return type is not in the signature again. And let's look at this example. My class name is scope. Okay, scope.java. Let me see if I am going to have, I am going to have another class called scope test. Maybe we should look at the scope test first. Scope test is a simple class that includes a main method. I am going to make a new scope object, and I'm going to call this method begin. Okay, that's what it's going to do. Buramam lazım. Efendim hocam. Teşekkürler hocam, buyurun. Hocam ona ben evet demiştim. Ben hatta credential'larımı da göndermiştim ben ona. Evet. EKG verili. Bilmiyorum ki hocam ya, başkasının ismine söz vermek istemiyorum şimdi hocam ya. Ben idare ederim hocam. Eğer olursa başkasına söylerim ben. Yani başka üniversite. Hocam senin, evet ya, istiyorsanız bana bir süre verin, ben akşama doğru size döneyim, olur mu? Evet. Olur inşallah hocam. Oldu hocam, teşekkürler. It was the boss. I had to answer it. You know what he does to you if you don't answer it? He's a very angry man. Okay, so let's go back and let's look at this class, the scope. So I'm going to forget this one. This is the class scope. I have a private integer initialized to 1. I can do that kind of initialization in C++ 11 too. We usually don't do it, but it can be initialized. And it looks like I don't have any constructor for the scope, right? Yeah, I don't have any constructors. Yeah, well, I mean, since there are no constructors, it's like the default constructor. Everything will be initialized to their default values. What are the default values for the fundamental types? It is all 0. For the Booleans, it is false. For the reference types, it is null. Okay. The initial value for reference types are null if you don't use the new statement. But in this case, I have only one integer, and its initial value is always 1. Okay, if I call begin, it looks like, okay, I have a local variable x which has the same name as my field name x. Okay, so this x is going to shadow this x. Okay, this one is in the shadow of this x. When I say print x, it will print 5, right? This is going to print 5. It's not going to see this one. Okay, Then it calls a method named use local variable. Then it says use field, use local variable, use field. Let's look at those two functions actually. Those two functions. Here is our local variable. Okay, this one defines another local variable x. Okay. When I call this one, when I call this method, definitely it will print here. It will print 25. Then it will increment it. It will print 26. Doesn't matter how many times. Doesn't matter how many times we call this use local variable. It's always going to print 25 and 26, right? Because it's a local variable. But if I call use field says that I am going to print x. What is x? X is my field integer or data member in terms of C++ terminology. Okay, x is my field and its initial value is 1. So I am going to print 1. Then I am going to multiply x with 10 and reassign it again. X will be 10 and I will print 10. So every time I call this use field, it's going to keep changing my field variable x. So first it's going to print 1 and 10, second time 10 and 100, third time 100 and 1000, and etc. Okay, so this x is not shadowed. Okay, this x is shadowing my local variable. This x is shadowing my field variable again, and this one is shadowing my field variable again. So what do I do? So this will print. What do I have here? This will print 5, right? This one will print 25 and 26, right? 25, 26. This one will print 1 and 10. This one will print 25 and 26. And this one will print what? 10 and 100. Because use field modified my field integer x. That's what's going to do. And how about this one? This one will print line 22. It will print 5 again. Okay. None of these can modify this x value. None of them can modify this x value. Why? Because this is my local variable. I didn't send it as a call by reference or anything, call by reference or anything like that. Okay. Good. So this is just a simple example to show you how this scoping and the shadowing works. Any questions? Okay, so test this yourself. Write the same program, try to modify stuff. Try to get the same behavior that you get from the C++ compilers, and you'll understand it better. Okay? There are no questions. I will start talking about the arrays. Arrays are kind of similar to C++, but since there are no pointers, I mean the pointers that will the pointers in Java are shared pointers, okay? And you don't touch the pointer itself. You don't say, give me the pointer. It is all hidden. And we don't have the same flexibility of C or C++ about the pointers. So we like to use pointers with arrays a lot in C, C++. In Java, we don't, okay? In Java, we make arrays and we index them. We access its elements, and that's it. We don't use any pointers with arrays. That's the main difference. Okay, so this is how you make an array in Java. Okay, arrays are again reference types. They are not fundamental types, so they have to be created using this new operator. Here's I am making a new integer array of size 12, and I am referencing it through a array reference, Okay. Array reference type is integer array. So this is the type of the integer array reference. This line is equivalent to these two lines. Make an array reference. The value of C is null here. Now it is not null. So there is an array of size 12 on my heap, and I am pointing to it using the C. Okay. As I said, C is don't think C as a point. It's a reference. Okay, it's just a reference. You cannot increment C. You cannot do stuff with C that like we did in the C++ C. So don't. If you are missing the pointers the way they are in C, C++, go back to C, C++. Java is not a language for you. Okay. In Java, you are not going to think about pointers. You are not going to think about memory or what the CPU does and etc. or the stack most of the time. You just follow the rules, and these are the rules of the game for the Java developer. So C is an array, and you can access the elements of the array C by their indexes, index number 0, 1, 2, 3, 4, etc. It goes that way. There are a few more conveniences that you can use with the arrays. For example, C.length returns the length of the array for you. Okay, so you don't have to send the length of an array when you send this to a method. Okay, so it's an object actually. So when you say C.length, you are going to get its length. And as an exception to the other stuff, array initializer can be used. I am making a new array, and these are the initial values. And of course, the multiple dimensional arrays are possible. What you do, you say integer square bracket and another square bracket. That means it's a two-dimensional array. Okay, let's look at this array example. Very simple example. I have an integer array. This is another way of declaring array references. I like this one better. Integer array. Okay, I like this one better because this is my variable name, this is my type, right? Type and variable name, but this is okay too. I prefer this one. Okay, most people prefer this one. So array is a array reference, and I am initializing it with a array of size 10. Okay, and in a for loop from 0 to array length. See, I know the length of the array from now. Okay, and I increment the counter by 1, and I print the array content using this statement. So 1 decimal and another decimal. Okay, counter and the array counter. So it looks like all the array elements are initialized to 0. Good. Integers are initialized to 0. Okay. Any questions on this? Yeah.
So, sir, if I'm done with the array,
What's that?
if let's say I'm done with the array,
Yeah.
I don't want to use it anymore. There is no way to delete it from the memory.
Well, I mean, there is no such word as delete in Java. No, you don't think about it. If you are done, then don't use it. If you are really, really bothered about what's going to happen now, I don't want to use it, maybe you should just say array is not null, right? When you do that, since nobody is pointing to this array anymore, garbage collector may come in and throw it away, delete it, but it is not guaranteed. You don't know when the garbage collector is going to run. You may force it to run, but that's not how the Java programs work. You don't think about it, okay? This is not C. This is Java, okay? And in that world, you behave differently, okay? You don't behave the same way when you go abroad. If you go to USA, you behave differently. You become another I obey all the rules of the traffic in USA. I never run the red light. I never use the emergency lane. But in Turkey, it is okay to run the red light and use the emergency lane and swear at the other people, and those are kind of nice stuff in Turkey, right? We all do that, yeah. So don't do this. I mean, if you do this, well, nothing happens. I mean, if the compiler compiles and it runs, yeah, that's fine. That would work. But this is not Java programming. Sometimes we try to be optimal, but I mean, if optimality is your concern, again, Java is not your language. Okay, if optimality is your concern, Python is not your language. Okay, especially for Python, fast development. I mean, lots of libraries and easy to use, lots of tutorials, container stuff. You just copy paste and it works, and you make a few modifications without understanding anything. Everything works and that kind of stuff. That's how the Python works, and Java is kind of in between C, C++, and that kind of work. In Java, at least you know what's going on. In Python, you don't have to know what's going on. Okay, good. So, okay, I am out of time. When I come back, okay, this was a simple example, but this was an example of primitive types, fundamental types of arrays. Okay, what happens if I like to make arrays of money objects? Okay, money array of 10. Okay, we are going to look at that one when I come back. So, money array. We will be here at 10:40. Okay, 15 minutes. Şu pencereleri açalım arkadaşlar ya. Ben yoklamanızı unutmayın bu arada.
Şey değil mi? Çakma mı?
Çakma Java.
Benziyor mu?
Şey mi? C# aşırı benziyor.
Çakma Java değil mi?
Saç direkt aynı zaten.
Java mı?
C# Java çok benziyor.
Ne oldu? Ben görünüyormuş.
var mı acaba? Nasıl? 7 tane forvet var. Kaleci bir de forvet. Buna da forvet oynuyor.
Yok aklına gelirse sor.
Hazır yanındayken.
Hadi başla.
Şimdi atacağım sana. Cevapları.
Cevap gördün mü?
Cevap sevmem bu arada.
Yok burada.
Ben de.
Kanka. Ben bundan sonra
Ondan sonra ben de ona göre.
yazın Discord'a yazmış. Bunu direkt yazayım. Gördün mü sen geçen gün çocuğu
Kolay
yazmadı.
kolay.
Ben Discord'a
Aşırı
hiç
basit.
girmedim.
İyi
Yine boş.
soru. İnşallah
Göstereyim
gelirsin.
tarzını. Yazamadım, kayboldum.
Tamam ama aynı.
Öyle adım çıktı. Derin Ömer'i dalga geçiyor ya. Oğlum durduk yere bana kaldı. Şimdi onun ortasını bir galiba bana kaldı. Ne oldu anlamadım.
Olmadı cevap ben yazdım ona.
Aynen.
Ben de soru sayısına bakıyorum.
Bak yapalım diğer uzun üstüne kaldı.
Bir şey olmaz. Ben aradan
Tek
çekeyim.
başına yapanlara helal olsun. Ben de devre iyi biliyorum.
JavaScript'miş.
Ama imkanı yok tek başına.
JavaScript yazmışlar acaba yazmamışlar.
Neyse işte o soruların ilk 12 soruya cevabı yok. Ondan sonra hatta yaptığını göstereyim.
İnşallah bundan sonra bir
Tamam şey yaptı. Üstüm olmadı.
Sanmıyorum.
Bitir dersini ve seni falan diye.
Sanki valla sana yapacak bir şey yok. Kesin
Bak şu
doğru bir baktım yok ya.
10 soru aynen.
Teknolojisi de
Cevabı
tamam var
yok.
benim.
Bunların
10 soru. Böyle şeyler var.
Acaba
Okay, so let's I have an array of money array, right? MA, and I make a new array, of course, new money, like this one. I say 10. So this one makes an array of money references, not money array. Okay, it's an array of money references. So if I draw the memory version of it somewhere. Where? Yeah, here it is. So it's like this money array is here, MA. Somewhere in the memory, I have 10 spaces, and this one points to it. Each of them is a money reference, and their initial values are null. Okay, their initial values are null. So if I say MA0 get dollars, Okay, this one will give me a runtime error. It's going to tell me that this is a null reference. You can't do that. Okay, so what am I gonna do? I need to do something like this. In a for loop, integer I from 0 to ma dot length plus I ma I new money. Okay, $10.21 or $10.08. Okay, so that's kind of the I mean, the idea was it is the same, but usually when we write these kind of arrays, people are confused. People coming from C++ are confused. They think that this is an array of objects. No, you cannot get array of objects in Java. It is not possible. All you can get is array of object references or array of fundamental types like this one. There's an array of fundamental types, integers, doubles, booleans, etc., or array of references like that one. Okay, so you have to initialize it with that kind of case. Remember, we had a problem in C++. If we didn't have the no parameter constructor or default constructor, you cannot make objects, you cannot make arrays of those kind of classes. You remember that? Because it said that I don't know how to initialize each of those objects in C++. But in Java it is possible. Why? Because this statement doesn't make 10 money objects. It makes 10 money references. To make money objects, you need to use new operator exclusively, one by one, explicitly, one by one. And you get to choose your constructor, which constructor you like to call for your array elements. And if you like, you can keep those values, MA values, as null, and that would be it. Yes?
Doesn't the compiler initialize the array?
It initializes with null, correct, null values. Okay? As I said, a reference could be a null value or a valid value. There is no garbage value for a reference. You can't have it. If there is a way of doing it, it's called hacking. Of course, I mean, this software world, everything is possible, but if you follow the rules, okay, if you are not doing anything intentional like that, it is not possible to get a reference of a garbage value. There is no memory leak. There is no dangling references in Java other than the null references. Okay, so all this at the cost of this reference counting, smart pointers, and garbage collector. Okay, for those you need to spend some memory and spend some CPU time. Good. Any questions on this? Okay, so like that, if you have two-dimensional arrays, remember the dynamic arrays that we did in C++, you can have non-rectangular type of two-dimensional arrays. Each element of an array is a different size array. You can have that too. It is all possible. And another nice thing is that you don't have to delete any of those money objects. They are automatically deleted when nobody refers to them. Okay, good. So these are the arrays, and these are the, again, as I said before, these are the arrays that Java directly supports, and there is lots of array kind of data structures inside the standard libraries of Java, which we call Java collections library. Okay, like the array list and the lists and etc. When we come to them, we are going to talk about it. In fact, the next semester we are going to look at all of those structures using Java programming language to study each of those types. Starting from Java Standard Edition 5, enhanced for statement, or in C++ what we call range-based for statement is available, like this one. You put your parameter here and the array name there and your statement. This is called array enhanced for statement, and here's one example. Okay, so this is a special notation for array initialization without using a new operator. you are making without using a new operator, you are making a new object and initializing it. Okay, these kind of notations are not possible for your own classes. It is available only for the arrays and the strings. Okay, I have this array and line 12 and 13. I am iterating over the elements of this array, and I am incrementing total by the number. Okay, so total is initially 0. I increment it one by one, and I print out total at the end. Java initializes all the data members or the fields to their default values, which is 0 for the fundamental types, which is null for the reference types. But if it's a local variable like this, okay, total is not a data member or the field, okay, it's a local variable. If you don't initialize it, it doesn't get initialized. So if you use this one, total plus assignment, you are going to get an uninitialized data error or something like that. Okay, it has to be initialized. So I kept it initialized. Good. So enhance for is there. We could use if you like. And starting from Java Standard Edition 10, we could use these kind of declarations like the auto keyword. So this one is enhance for. Okay, it's called enhance for in Java instead of range. Okay, remember this stuff. Okay, in C++ it is range based for, and in Java they call it enhance for. In C++, auto keyword for type deduction. Okay, in Java, starting from Java SE10, they call it var. Okay, variable, and it works like this. Okay, this new array list string, okay, it is making a kind of, we call this generic in Java instead of templates. Okay, we call it generic. We are making instantiating an array list with a string, and instead of writing the whole type name there, I just type var. Okay, instead of auto, just write over. Okay, I don't know what kind of object it is returning, but all I'm saying is that var path is paths.get. Okay, so we know what auto does. The corresponding keyword in Java is var, starting from SE10. Good. So it's another important difference from C++, especially from C++. In Java, everything is passed by value. There is no call by reference in Java. They say that it is both available, but that's not true. It's like C, okay? In C, we don't have call by reference, right? In C, we don't have call by reference. We have simulated call by reference, but we don't have call by reference. In C++, we have call by value and call by reference. In Java, we have call by value only. That's it. We have call by value. If you are passing an integer to a method, that integer has to be copied, okay? If you are passing a double to a method, that double has to be copied. If you are passing a reference to a method, that reference has to be copied, okay? Copying a reference doesn't mean that you are copying the object, okay? You are just copying the reference. It's like copying the pointer, copying the reference. So if you copy the reference and if you modify your object through that reference, you kind of end up modifying your object. It looks like a call by reference, simulated call by reference. All you can do is this. So most of the time in books or documentation, they say that the Java has both pass by value and pass by reference. For the pass by value, they say that every primitive is pass by value, call by value. Okay. integers, doubles, floats, and bytes, and etc. For pass by reference, actually you are passing the reference. Reference is copied, and through the reference you can modify the objects. Okay, but as like in C, you don't have actual call by reference or pass by reference in Java. Everything is pass by value. Okay, everything is pass by value. Since arrays are reference objects, okay, their references are passed by value, and since they are passed by value, I get the reference itself. I can modify the array itself using that reference. Okay, so maybe I didn't see anything new here, but this is just a way of looking at things. I don't agree with this statement from this book, wherever I copied the slides, I don't remember, but usually they say this. I don't agree with that. In Java or in C, there is no call by reference. It is all by call by value. Everything is copied. Okay, everything is copied. Since there is no way to touch an object in Java, you cannot get an object in your hand. You can have the object reference in your hand, but not the object itself. You cannot send an object to a method. Objects are not sendable to methods. Okay, only the references can be sent to. Okay, objects cannot be assigned because I don't have a name for an object. Okay, objects doesn't have a name. References have names. All I can do is just copy the references. That's what I'm doing here. That's what I'm doing here. Okay, in C it is possible to pass whole structs as parameters, right? In Java, no. There is no way to pass an object to a method. Okay, you may pass only a reference of that object to a method. Okay, yes.
Can function returns locally created array, for example?
Sure, why not? I mean, you could do that, and in fact, it is safe to return them. Well, this is not safe. Let's say I have a, well, okay. Let's say I am returning a money reference from a function f. How would I return a money reference? I would say make a, okay, here it is. Return new money, $10.20. I returned it. Is it safe? Yes. Why? Because if somebody gets a reference to it, they can keep using it. If nobody gets it, it will be deleted automatically. Okay. Since in Java you don't, okay, you might say that, okay, I'm going to return a reference to a local object, but there are no local objects in Java because everything has to be created on the heap. If you say money G, okay, money M, and return money M, okay, this is not returning an object, this is returning a reference. And since I did not assign anything to this one, it just returns a null reference, that's it. This is not a money object, so there is no returning of objects themselves in Java. Only you can return object references, or only you can return fundamental types. There is no returning of objects, or there is no passing of objects in Java. They have prevented. So what did they gain? First of all, it is efficient. Why? Because sending whole objects to functions or returning whole objects from functions is expensive, right? That's why we used to use constant reference to send objects in C++. So they prevented this. They say that, okay, we are not passing objects anyway. Objects are there. We are only returning their references. We are sending only on their references. This is efficient. Okay, this is efficient. So we gained lots of stuff. So as long as I keep counting the reference numbers for those objects, I should be safe. Very, very nice, very smart solution. By the way, the designers of Java were expert, very, very good C++ programmers. Okay, they spend their lives writing C++ code. After that, they designed Java, so they know C++ much better than many people on this earth. Okay, so They know the shortcomings. They know the mistakes people make with the C++ word to make the development life of a developer more efficient, faster, and less troublesome. They made these kind of decisions, and most of them turn out to be nice solutions. Some of them have problems, of course. Most of them turn out to be nice solutions, and we kept using Java for the last 30 years. So it has been 50 years for C language, and 30 years for the Java, and both of them are being used a lot. You had a question?
So there is no move semantic in Java.
Exactly, that's a very good point. There is no move semantics in Java. It doesn't make much sense. It doesn't make sense because I am not assigning an object to another object. What was the point of move semantics? If I am doing the assignment, instead of copying the content of the other object, I was stealing it, right? Well, in Java, I don't have any object assignment stuff, right? I don't have any object assignment. Maybe I can do the cloning. Maybe I can do the copy constructor stuff, but no, it is not. It is not needed. Even if it is needed, Java is okay with taking that kind of performance hit. Java is not claiming that I am the fastest in the world. Okay, they say that you are. When you say that, well, you are slow because you are running JVM. They say that, oh yeah, that's fine. That's fine. It's like 20% hit. It's much better than spending 2 months trying to figure out one memory leak of a large program and rewriting your program from the beginning, etc. Okay, so I have CPU power, I have the memory. Why not just use some of it for this kind of JVM and garbage collection, and I will be safe. So that was a very good point. There is no more semantics in Java. When in fact, I don't think other than C++, any language defines such a thing as move semantics. Because without the move semantics, we were happy, right? We were happily writing our code. Everybody loved everybody, so no problem. But with the move semantics, we gained a little bit speed. Okay? Without the speed, Java is okay, Python is okay. Even if I wanted to add it, it is not possible because this garbage collection is making stuff. I mean, remember how we did the move semantics? We steal the resources of the other object and we left it to be killed, right? Well, we don't make those kind of decisions in Java, okay? Only garbage collector makes that decision, okay? When the object is going to be killed, and if that object is not killed after we're done with the move assignment or move constructor, then we would be in trouble. So, yeah, so that's a good point. Yes?
We said that call by reference actually call by value. Isn't that the same for the C++? Since you actually pass a pointer like a reference.
Well, under the hood, yes. I mean, under the hood, there is no call by reference in any language because everything is converted to assembly language. In assembly language, you don't have call by reference. That's true, but in C++, I can write stuff like void f integer reference I, right? This is call by reference. When you send an integer variable, okay, I can modify that integer variable. That's how the semantics of the language work, okay? In Java, this is not possible. That's what I'm saying. I mean, whatever you send, it will be copied. Since you cannot send objects won't be copied, but their references will be copied. It's like C, okay? So the way Java works in terms of call by value, it is exactly the same as, well, it is exactly in quotes, same as in C. Okay, yes?
In the first function, how am I be able to return object reference that is filled in the function? So it's returning to the new object reference.
Yeah.
That is not filled in the function or managed or changed in the function.
You would like to return an object that is not filled.
And like change in the function or implemented in the function.
You like to return a, well, in that case you have to get this from somewhere else, maybe through the parameter. I get a, okay, I accept the money object M. I did about M something, M dot something something something, I return M. Okay, so, or maybe you return money reference, which happens to be your private field member. Okay, so it's not much difference from C++. Good. Okay, so these are good questions. I sometimes feel that you have been listening to me. Is that what you have been doing? You have been listening to me for the whole semester? No, okay, good. So in Java, like in C++, C++, this variable length argument links are possible. Well, maybe I shouldn't talk much about it, but okay, let's look at this main method. Main, I have 4 doubles. It is possible to call this function average with 2 doubles, 3 doubles, or 4 doubles. The same method, okay? So this is called variable length argument list, and this is how it is done. You say that I am expecting some doubles. I don't know how many, okay? I don't know how many. So when this function, then when this method is called, Java makes an array of those doubles as an array double and gives it to you. So these numbers are actually array doubles, arrays of double. Okay, if I iterate over this numbers array with this, I get it. So it is possible to make these kind of calls with 1, 0, 3, 4, 5, 6, whatever. But the thing is that all the parameters have to be doubles. Okay, you cannot mix it like double integer, etc. There is a way of doing that, but I don't want to go into that. Okay, so remember, because we could do that kind of stuff in C2 using the macros. What else? Command line arguments. Yeah, remember how we write, remember how we call or how we run our Java program. You will say Java my class. Okay, there should be a my class named my class compiled in the current directory, and you call it like this one. Yeah. Okay. Java. What do I have here? Main. Do I have main? I don't have main. But do you? Add num. Yeah. Add num. Okay. This is how it works. Okay. If I provide 1, 2, 3 command line parameters, it takes these 3 command line parameters. But since my add num doesn't use any of them, it didn't change the results. But this is how you send the command line parameters to your functions, to your programs. Okay. So this is how I send them. So how is that passed to your programs? It is passed to your programs using this main methods arguments. Okay, so it's a string array. Remember this one? It's a string array. So I am saying that at the beginning of the program, I am saying that if the number of command line arguments is not 3, then I will stop. I will say, please enter the entire command, including the array size, initial value, and increment. Okay. By the way, let me run the program. Let me show you the program, and after that, we are going to look at it. So, when you call this program Java init array, it gives you an error message and it terminates. When I call it this way, Java init array 504, it makes an array of size 5. It starts with the value of 0, and it increments that value by 4 and fills in this array like that. Okay, so that will be an array of size initialized with these values, starting from 0 incremented by 4. Okay, if I run this again, array of size 10, I will start with the initial value of 1, but I will increment each value by 2. 1, 3, 5, 7, etc. It goes that way. Okay, so this program, simple program, is used to initialize an array of size something, initial value and increment value. Let's do that. Okay, so I get all those values as a string. So those are not numbers, those are not integers, those are strings. So I have to convert those strings to integers. Okay, so that's what I'm going to do. So if the array length is 3, I have those 3 numbers. Okay, my array length will be the argument number 0, but I need to convert that string to an integer. This is how you convert strings to integers. There is a class named integer inside java.lang package. Integer with a capital I. Okay, that class has a method, static method of course, because I am calling it through the class name. That method takes a string and returns an integer if it can parse it. If there is an integer inside that string, it will parse it and it will return that integer and assign that integer to this array length. Once I get the array length, okay, I make my new array of size array length. Okay, my initial value will be my second argument. Again, I parsed it, I get the initial value. So this parse is kind of like a to I. Remember C function a to I, alphanumeric to integer a to I. Okay, it's like that function. So I am using this 2 more times. Argument number 1 will be parsed into initial value. Argument number 2 will be parsed into the increment. And this is my nice for loop from 0 to array length. Array length is the same as argument 0. Okay. And I increment the counter by 1. So array counter gets the value of initial value plus increment times counter. Simple code just to show you how the command line parameters work. After initializing them, I put this nice header, two strings formatted. Formatting works the same way as in C, and I print them out using a for statement. Good. So as simple as using that, well, it is simpler than using the command line parameters in C++, because in C++ you have to pass the array of character arrays plus the number of the elements in it. Since this is a standard Java array, it has its length. Okay, it has its length property with it. Okay, so no problems. By the way, this length is not a method. See, it is just direct field itself, public field, which is not good in terms of object-oriented programming, but I guess to save some time from calling that function over and over again, or method, they made it a field. Good? Any questions? Okay, if there are no... Yes?
Getters functions...
methods.
Methods. Returns not... should returns not reference, I think.
Why not?
Because it's getters, and we just want to the value, not change the value.
You are saying that if I return a reference to my private object, right? That's what you are saying. Other people can modify it, and that's what I don't like. Well, yeah. Well, if you return a string, that's okay, because strings are not mutable, right? So if you are careful, then you should be fine. But if you have a money object in your class as a field, as a private field, and if you return it, yeah, they can change your money object. Yes, that's true. And since there is no const keyword, there are no guarantees that nobody is going to change it. But there are some ways of achieving that actually, and we are going to see it after the inheritance. We are going to see it. So it looks like this. It looks like this. I have this hierarchy. Here I have money constant, and here I have money. Okay, inside money constant I have get dollars and get cents. Okay, inside money I have set dollars and set cents. Okay, if I have a money object in my class, I don't return a money reference, but I return a money constant reference. Okay, because there is a relationship between them. If I return a money constant reference, they cannot modify their values because there is no set element in it, right? So that's how you do it. So that's the beauty of the inheritance, right? That's the beauty of these relationships. So Java uses this idea a lot. But you might say that, well, I don't see an easy relationship between them, right? I mean, I kind of abuse this notation. Money is not a money constant, you might say. I mean, every money object, well, every money object can behave like a constant money object or immutable. Maybe I shouldn't say, okay, maybe I shouldn't say money, but I should say immutable money. Okay, so every money object can behave like an immutable money object. And if I return a reference to immutable money, they can only use these two methods, not these two methods, and I should be fine. Okay, so these kind of solutions are possible, and they are widely used in Java. Did you get this question? This was a very a nice point and question. I mean, well, what am I going to do with my internal object? I mean, since there is no const keyword, you cannot return a const reference, right? All you can return is a reference, and everybody can do whatever they want with my objects if I return them. So since they are not constant, I am saying that don't return money, return immutable money. Make a hierarchy like that and return that one. You might say that what happens if they do a downcasting? Okay, they would downcast whatever I return to a money object, and they modify that stuff. And well, I mean, they are shooting themselves in the foot, and it is their problem now after that. Okay, so those kind of things. Java doesn't say that I am foolproof. Java says that I am going to help you. No programming language is foolproof. If you're gonna do foolish stuff, you can do it everywhere you like. Okay, if you like to hurt yourself, then hurt yourself. I mean, it is very easy to hurt yourself in C++. In Java, it is a little bit difficult, but it is not impossible. Of course, you could do that. Good. Okay, let me move on. Overloaded constructors is possible, like the overloaded methods. Let's see one example. And like the constructor delegation in C++ 11, there is a way of calling the other constructors in Java. Let's look at this nice time class. Well, its name is time 2, but read it like time, because the slides that I borrowed from, they had a number of time classes. This is time 2. I have 3 private fields, hour, minute, and second, all integers. Constructor time, no parameter. Okay, constructor time with a single hour, constructor time with hour and minute, constructor time with hour, minute, and second. Okay, and constructor that takes another time object. It looks like a copy constructor. In Java, we don't have a separate term for the copy constructor. There are no copy constructors. Okay, you might say that, well, this looks like a copy constructor. Yeah, you can call it if you like copy constructor, but in Java terminology, there is no such thing as copy constructors. Okay, copy constructors are for C++ only. Okay, in Java, the standard terminology or standard way of copying stuff is using the clone method. You clone the objects. Okay, so let's look at this one. This one says that I am going to call the constructor that takes 3 parameters. For this, I am using this keyword. This keyword is the same as in C++, but it is used this way. Okay, so I am saying that As the first executable line in your constructor, you make this call. Okay, this is important. As the first executable statement in your constructor. Okay, if you do this in another line after doing some initialization, etc., it doesn't work. It's a compiler error. Remember, we used to do this with in C++11. We used to say column and time 2 and 0, 0, 0. Remember this?
Yes.
Constructor delegation. This is another way of doing the constructor delegation. Okay. And the same thing is here, and same thing is there. In Java, we don't have the default arguments. If we had the default arguments, actually, if we had the default arguments, this would have been enough, right?
Yes.
In Java, we don't have default arguments. The reason why we don't have them, I don't remember. There is a problem. I mean, this JVM makes things a lot difficult for Java from time to time, because I mean there are things that are happening during the runtime, and that's going to be problematic. Okay, so this is how we do the overloaded constructors and how we do the constructor delegation, calling the other constructors through this reference. Okay, as you have guessed, okay, there is no arrow operator in Java. Everything is dot operator, because they say that we don't have any pointers. But in fact, everything is pointer. So in fact, let me do this. Well, I mean, all the things that I am saying here, that would make a seasoned Java programmer mad, actually. I mean, if they can sit in this classroom, if they listen to me, well, some of them might be insulted, but I mean, anyway. So let me write this very carefully. I don't want to confuse anybody, but yeah, okay. In C++, the arrow operator in Java is dot operator. Okay? Because in C++, in Java, everything is referenced through references. References are smart pointers. Okay? And there are no dot operators in Java. Sorry, but is that? I mean, not sorry. I'm not saying sorry for you. I mean, saying sorry for the Java programmers. Good. Okay. I think I am out of time. Let me stop here. Please read the whole slide set and try to understand what Java is by reading the stuff from the web. Next week you are going to get your first Java program homework. Yes. I forgot the attendance sheet. What am I going to do? Do you guys have time? Is there anybody who didn't come to class today? Are there any? I think. Oh, well, what? No. Well, you mean? Okay. Could you start attendance from there? And I need to leave now because I have to be somewhere else. When you are done, please somebody bring that sheet to me and slide it under my door upstairs. Okay? Who is going to do that? Someone. Okay, you are going. Okay, thank you. So put the date today at the top. Why didn't you remind me at the beginning of the class? I printed it out and didn't bring it here. Sorry. Next week on Tuesday we have a guest speaker. I think I put the details on our Teams page. Our Mustafa, who graduated like maybe 10 years ago. He's going to talk about some object-oriented techniques that he uses in his daily software engineering manager life. So if you don't believe me, you're going to believe it, sir.
Hocam slaytları atacak mısınız?
Saatleri koydum ya şeye.
Koydun mu?
Koymuştum, dönem başına koymuştum, tamam ama bunların bazılarını şey yaptım, değiştirdim, onun için değişenleri biraz daha koyayım ben.
Ben göremedim burada da.
Yok koydum. Arkadaşlar Java slaytları yok mu web sayfası şeyde? Yap. Öyleyse unutmayın, ben bugün şunları yükleyince onu da koyarım.
Hocam akademik projelerde lisans öğrencisi aranıyor mu?
Efendim?
Akademik projelerde lisans öğrencisi aranıyor mu?
Tabii ki.
Başvurabilir miyim?